Right, we're going to look at a quick revision on cubic functions. First, let's have a look at a general form of a cubic function. Y, or f of x, is actually equal to ax cubed plus bx squared plus cx plus d. Here, a equals to x cubed. A itself is the leading coefficient, and d here is the y-intercept when x equals to 0. Now, let's consider just y equals to x cubed and y equals to minus x cubed. For y equals to x cubed, we call this a positive cubic. So here, if you've got a, which is a dilation factor, as positive, the shape normally looks like this for positive cubic function. Negative cubic function, it looks like this. All right. So here what we can say is as x approaches positive infinity, y approaches positive infinity. All right. And as x approaches negative infinity, y approaches negative infinity. For a negative cubic, as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches negative infinity. Alright, so you must know the distinction between y equals x cubed and y equals to minus x cubed. Now, let's look at the x-intercepts or the roots. So for cubic function, you could have 1, 2, or 3 roots. There's always one y-intercept. Then we look at point of inflection. Point of inflection is when you change from concave up to concave down, or concave down to concave up. So in this case, it's concave down to concave up to concave down. All right, so you've got here the slight difference between this one and these two is that even you change from concave down to concave up, here that is actually horizontal. You can see that there is no maximum, local maximum or local minimum in this case. So here, that is actually a horizontal line, and therefore it's called the horizontal point of inflection. Right, let's have a look at the forms of cubic function. So the general form is y equals to ax cubed plus bx squared plus cx plus d. So you could have the root form where you know in this situation there's only one root, this, 2 roots, and you've got 3 roots in this case. So for all cubic functions, irrespective of the forms, A determines the nature of the graph. So for positive A, like I say, positive A, it looks something like this. And negative A, it looks something like this. All right? And then generally you can use your class pad to determine the point of inflection and the roots when you have the general form of a cubic function. That is, if you're given the question in the calculator assume section. Next, let's have a look at sketching a cubic function. You need to determine the nature of the graph, positive cubic or negative cubic. So remember, positive cubic looks something like this. Negative cubic is this way. Alright, this is positive A, and negative A. You must determine, or actually, depending on the form of the function, you can determine if there's 1, 2, or 3 roots and the coordinates of the root. Generally, what you can do is factorize. All right, you need to know the remainder theorem to factorize. I will show you an example a little bit later. You can determine the y-intercept by substituting x equals to 0, or if it is a general form, read it from the equation. Determine the point of inflection using your class pad if required. If not, you don't have to worry about it. And if you have a grid of a graph, it is always good to determine one extra point to help you sketch the graph. That is actually a useful information. I will talk to you a little bit later and show you another example. Right, you are now asked to sketch the function of fx equals to 2x cubed plus x squared minus 7x minus 6. And then state the range of fx if the domain of x is x greater than 0. Alright, before we state the range or domain, let's sketch it. First, we know the shape. This is a positive cubic. So it should look something like this. Alright? Now, let's determine the roots. So, for remainder theorem, you need to find an x where fx is actually equal to 0. Substituting x into fx, you get 0. And you generally start by looking at the factor of the constant. So in this case, you know the factor of the constant is 1, 2, 3, and 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Alright? Now, because I've already worked on this question, I know that f of minus 1 is actually 0. So let's try f of minus 1, 2. Minus 1 cube plus minus 1 square minus 7 minus 1 minus 6. Again, remember, always put in the bracket. Alright? The bracket is important so that you know you're actually working with the negative number. So therefore, we now know minus 1 to the power of 3 is minus 1. So that's minus 2. That is plus 1. That is plus 7. And that is minus 6. Therefore, there's 0. So therefore, x plus 1 is a factor. Alright? Now, you can do the long division or use synthetic division. I have shown you how to do synthetic division to find the other factor, and it's always, in my opinion, a little bit quicker to use synthetic division. Alright, now here, this is actually the remainder theorem. The remainder theorem said to me, or state that, if f of x equals to 0, f minus 1 is 0, x plus 1 is actually a factor. Alright, so remember, you need to use your remainder theorem. So for a synthetic division, what we do is to write down the coefficient. So 2x cubed, 1x squared, minus 7x, and the constant, minus 6. Here, the division, I use minus 1, which is f of minus 1. Alright, so remember, I bring the 2 down. So then, minus 1 times 2 will give me minus 2. Then I add them together. 1 plus minus 2 is minus 1. Minus 1 times minus 1, that will give me plus 1. Alright, so minus 7 plus 1 is minus 6. Minus 1 times minus 6 will give me 6. Minus 6 plus 6 is 0. So therefore, you know that f of x is actually x plus 1. And this is 2x squared minus x minus 6. Alright, so we can now actually factorize this bit. Alright, factorizing 2x squared minus x minus 6, you know that you need to find two numbers which multiplies to minus 12 and adds up to minus 1. So therefore, we know the two numbers will be minus 4 and 3. So if I rewrite this, I can split the minus x into minus 4x plus 3x minus 6. And then we factorize this bit by grouping. So by grouping x plus 1, I have 2x squared, x minus 2, plus 3, x minus 2. So therefore, the whole function of x factorized to x plus 1, 2x plus 3, and x minus 2. Alright? So now we can find the intercepts, the y-intercepts. Read straight from the general form, which is 0 minus 6. The x-intercept, you know that there will be 3 of them. Using the null factor law, I'm just going to write it straight out. The x-intercepts will be minus 1, 0. The second one will be minus 3 over 2, 0. And finally, the next one will be 2, 0. So now you actually got the 3 roots. Now let's sketch the cubic function equals to 1. So if, let's work out f equals 1, which is 2, 1 to the power of 3 minus 1 square minus 7 times 1 minus 6. So 2, this is plus 1 minus 7 minus 6 is plus 10. So therefore, did I say 10? It's actually minus 10. My fault. It's minus 10. Minus 10. Alright. So if it is minus 10, you know that. Alright. What I'm going to do is, generally, like I say in the test or exam, you'll be given the grid. But I haven't got a grid here, so I actually have to use a ruler to draw it. Remember, always use a ruler. Y and x. Alright? So we know the 3 roots. One is minus 1. Minus 1, 0. The other one is, let's say, I'll go a little bit further. This point, minus 3 over 2, 0. Alright? And then the next point is 2, 0. Now, you know that the y-intercept is 0 minus 6. So you've got 4 points. The only concern now is when you draw this. Alright? This point here, whether it is actually to the right of the y-axis or the left of the y-axis, which is between minus 1 and 0. Alright? So therefore, it is good to actually work out another point. Here, I'm going to work out when x is, you actually know that this point would be, when it is 1, is somewhere here. Alright, minus 10 is below minus 6. So therefore, the local minimum will occur around here. We don't know whether it's minus 10 or not. So what we can do is, we know an extra point, 0, which is 1. Let's say here, 1 minus 10. 1 minus 10. Alright, this is just help us sketch it, that's all. So sketching it, I'm going to do it slowly. So it could be, and here we don't know the top. Alright, so that's how you do it. You know this point, we don't know whether it's a local minimum or not. So doesn't really matter. Here, I think I better try to draw it a bit better. It goes up probably this way. Alright, so therefore, you know that this is y or function fx equals to 2x cubed plus x squared minus 7x minus 6. Right? That's all you need in terms of sketching. Now, the next thing you need to think about is the range. You are looking at the range for x greater than 0. So you know that domain of the function is x is such that x is real number and x is greater or equal to 0. Alright? So therefore, what we are looking at is here. Alright? The domain is over here. Now, because we don't know the minimum point here, what we can do is use the calculator if this is in the calculator section. Alright? So we know if you plot the graph in the calculator section, the minimum point is actually, I use a different color, using iPad, oh not iPad, your class pad, the minimum is actually 0.93 and minus 10.04. So therefore you know that in this case the range of fx will be, fx is such that fx is an element of a real number and fx is actually greater than equals to minus 10.04. Alright, so you will only be asked in this situation, you'll be asked to find, when you're asked to state the range, use your class pad if this is in the calculator section. Alright, I'm going to stop here.